This is the third of 4 videos on TdBench version 7.2, which describes how it works. TdBench is supported on Linux. It is best to use Teradata Managed Server, but in a pinch you can run it on a node because the minimum software requirement is to have BT available. If you don't have the other utilities installed, you won't be able to use the tools to back up your work, run speed test, use the TPC benchmarks, or wrap up your work at the end of an engagement and archive it. The SWS and Viewpoint servers have no Teradata utilities installed on them, and I'm not aware of anyone successfully installing on one of those. The setup for earlier versions of TdBench worked okay if you were doing a benchmark on a server in the benchmark lab, but when working at client sites, we often don't have rights to log on as DBC or root. TdBench version 7 separates the creating of users and granting of rights from the installation of the software. There's a menu option to validate the environment, and it will produce a shopping list of the create statements and rights that the DBA will need to execute if they won't give you the passwords. The install will create directories and install benchmark tools on both Linux and Teradata. Importantly, setup creates a test tracking table, which is used to keep track of the run IDs assigned to each test execution. Its title, notes on the execution, environmental information about the configuration, TASM settings, and database version are all recorded. Because we missed it on one benchmark, it also records how many nodes were actually working at the beginning and at the end of the test. Importantly for the reporting, it contains precise start and stop timestamps, which is used to pull data from dbQL and res usage. There is a set of reporting views that makes it easy to select dbQL and res usage from one run or to compare information before and after tuning activities, different scale factors, or reconfiguring the system. The test tracking table is joined under views to the dbQL and res usage information to select just those rows that occurred within the time period referenced by the run ID. New with version 7, during the setup you'll be asked if historical dbQL and res usage data is available from PDCR or from a prior Teradata release, and if so, we'll create analysis views joining current DBC data with history, with the intersection of column names available in both. If you say that PDCR isn't in use, setup will just create reporting views against DBC only. Then of course you need to set up the customer databases. You'll need to grant rights to the benchmark workers and login IDs that will be accessing that data. Let's start by looking at a simple serial test. When you run a test, you use the define statement to give the test a name, which assigns a run ID in the test tracking table. The queue statement merely defines a file to hold the queries for the test. You can queue groups of queries from a directory, a wildcard search, or one at a time enclosed in quotes. You can also use the worker statement to define how many workers will be associated with the queue. When you issue the run command, a process is started to manage the queue. It creates FIFO pipes and one for each worker used as standard input for BT, and one for the queue to allow the workers to request more work. The worker is then logged on, and its standard output is captured in a temporary directory. A queue is placed on the worker's queue, and by default, basic transactions are traced. And with version 7.0, the trace table also contains client performance and success and failure of each query executed. The query is read and executed by the worker, and when it is done, it puts its name back on the pipe for the queue along with the success or failure of the query. The queue master puts another query on the pipe being used for standard input by that worker's BT, and the worker starts executing that next query. And when that's done, the next query is executed. And the process continues for the serial test until all queries have been executed. At the end, a directory is created with the same run ID that was assigned from the test tracking table, and the logs, trace information, and commands executed and messages from TdBench for that run are saved. The commands and responses for that run are also posted to the test tracking log table on the benchmark database. For workload tests with multiple queues, it is pretty much the same thing. except that multiple queue statements can be used to populate different queues of work, where one might be reporting and the other is data mining, or one for finance and the other for marketing, or whatever. When the worker statement is executed to define the workers, it associates each set of workers with a specific queue. When the run command is issued, there will be a process created to manage each queue, each with its own pipe for workers to request new work. With multiple workers, each will have its own pipe for use as standard input to BT. The workers associated with the queue are started by that queue master. And each queue master then starts assigning work to its workers. As the workers complete a query, a worker puts its name on the queue master's pipe, and the queue master selects the next query and puts it on the worker's pipe to be executed. When the run is over, another run directory is created, and the logs and trace information is saved. To save on space, the bulky session logs are zipped up, but all the logs for a run can be unzipped with a single command. With TdBench 7, I've added OS workers, which work very similar to the SQL workers by taking their commands from a pipe and putting their standard output and errors to a worker log file. This is not just useful for putting data loads into benchmarks, but during the setup of benchmarks, you can easily load multiple customer tables in parallel. The TPC-DS and TPC-H tools built into TdBench generate load scripts as an example that have two OS workers loading load tables at once. This can be used for copying, unzipping, or collecting stats in parallel. When running fixed period tests, there is a sleep master that's started when the run statement is executed. When the time elapses, it puts a stop to the test. In prior releases, the sleep master put a stop on each queue. With version 7, I've added a queue for TdBench itself for command and control of the test, and it commands the queue masters to stop, kill, or provide status. That was done to allow the new db.sh script to interact with the benchmark via a standard interface. To request the status of a test to see if the response time or the number of failures, or to kill the test if you've made a mistake in setting up the test, such as failing to put the grant rights to the workers.